Hello everybody, my name is Paulo Drius Jr. I'm from Federal University of Rio Grande in Brazil, and I'm presenting now the project Modular Automation Kit for boom sprayer focused on local smallholders and family farmers, developed in Federal University of Rio Grande, but also Instituto Federal Sul-Rio Grandense, both in Brazil. So I'll talk a little bit about our IEEE RAS sign project. So the objective of our project is to bring precision agriculture for every farmers, including family farmers and smallholders. The idea is to develop a low-cost modular automation kit that will allow the reduction in the use of pesticides. But why family farmers? Family farmers are very important in Brazil, but also in many other countries, since they are the most producer of food instead of commodities. So we expected the project to have impact worldwide, since the family farmers are important in most of the country. Here you have an example to show the importance of this project. More than 90% of the pesticide applied can be lost and end up having no action in the field. It's, uh, it's a very important issue. There are room to optimize the application of pesticides. So the project is focused on a low-cost system in order to be possible to be acquired by small farmers. The project is divided in three parts. The first one is the lock series. The lock series is development of localization system using GPS and IMU in a smartphone. And the idea is to avoid to apply pesticides in places that you previously applied. That's the idea. The second model is the VO series. We are using standard cameras, RGB cameras, and the idea is to identify the plants and avoid to apply pesticides in places that you don't have plants, for example. The last model is the control series. The idea of the control series is to control the boom sprayer in terms of flow and also pressure in order to do an optimal application of the pesticides. So, the target of our project is the development of 3 automation kits. The idea of these 3 automation kits is to install it at the smallholders in a partnership with a family farmer union that you have here in South Brazil, and it's the largest one in Latin America, with more than 6,000 people, 6,000 family farmers. We expected to have high impact in Brazil, since you have in Brazil more than 600,000 people involved in family farmers. And they are the responsible by food production. The idea is to extend this project to other poor regions, for example, Latin America and Africa. And the project is not supposed not just to have economical impact. We expected a lot of environmental impact and social impact, since the reduction of the pesticides will impact in the life quality of the family farmers and also the, the preservation of the environment. So we'll talk a little bit about our background. So I have here one of our recent papers published in Latin American Robotics Symposium. The title is Low-Cost System to Optimize Pesticide Application Based on Mobile Technology and Computer Vision. In this work, we presented an implementation on a smartphone of computer vision system that is able to identify plants uh, and take action based on it. We do experimental uh, evaluation of the system on onion farms. So another work, a perception system for an autonomous pesticide boom sprayer, was published in 2019 Latin American Robotics Symposium. The idea of this is to update the road detection using expectation maximization. Although a very good results obtained, the computational cost is larger than the previous one, so it's not able to run on a smartphone. Another important work for our project is this, published in 2019 in Latin American Robotics Symposium. And the title is Pressure Flow Relationship in a Boom of Autonomous Robotics Automation Sprayer. And the idea is to propose a control of individual nozzles integrated with smartphones. It was also tested on onion plantation. The last work that I will present is a recent one published on IFAC World Congress in 2020. The title is a low-cost prototype to automate agricultural sprayers, and it presents the possibility of prototype one embedded solution to automate agricultural sprayer. And it also automates the sprayer using a low-cost technology equipment that's adaptable to any tractor-mounted boom sprayer, and it makes the machines accessible to smallholders and family farmers. Here you have some images of our prototype running on a real boom sprayer. That you can see the quality of the pressure in the top right, and the control of the nozzles in the bottom in the right. So we'll talk more about our team to developing this project. Our team is composed by me, Professor Paulo Jr., together with two partners from IFSU, Professor Fabio, that's responsible by our technical support, and also Andre Odoni, that's responsible by our field support size. It is a PhD on agriculture. We also have two master students, Luis, that is working on control series, and Gabriele, that's working on lock series. We also working with undergrad student. We have Victor Caniglia, that's working in lock series. In control series, you have Mariana Pinheiro, Vivian Aoki, and Jardel Prado. All of them are undergrad students. In VL series, we also have three undergrad students, Gustavo Nascimento, Aniele Lemos, and Eric Gonçalves. It's our great team to execute this project. So I'll talk a little bit about our going work. We are working on the control series. Nowadays, we are doing the definition of the sensors, pressure and flow, and also the microcontrollers in order to get a more robust system. We are working the project of the actuation of the valves, the communication circuits and the communication with focus on robustness and low cost. We are doing some tests in communication now using the CAN bus that's much more robust than the previous protocol that you have adopted. We also doing some evaluation between the communication between the low control system based on Arduino and the high the high level system composed of a Jetson Nano NVIDIA Jetson Nano board using CAN bus, but also I2C communication. You can see here that you are doing a waterproof system that will enable us to run in real field experiments. Uh, the development in terms of the VO series and the log series, we are developing a new dataset system containing onion and soybeans, since it's the most important here for family farmers. We are also evaluating the performance on NVIDIA Jetson of our previously proposed computer vision system and doing a quantitative analysis of state-of-the-art methods in terms of localization and also plants identification in the field. Looking for the log series, we are doing Android development in order to integrate it to our control series system. So that's a small presentation about our modular automation kit for boom sprayer focused on local smart holders and family farmers. My name is Paulo Drills, and if you want more information or if you have some question, please send one email or visit our website. Thank you.